Honors Chemistry. So this is part 2 of the answers video for lesson 13 on empirical formula. So at the end of part 1, I did this problem, number 4, and you can recognize it by the number of grams of each of these substances. Some of the latter problems were misnumbered, so I'm going to go ahead. I corrected them, and it's now been corrected, but you might have an early version where they're not numbered properly. The next one should be problem 5, and then there's a problem 6 and 7. So I'm going to skip 5 because the answer to this is given on the instruction video. So go watch the instruction video, and both 4 and 5 are the same numbers. These numbers you see here for number 5 are on the instruction video. So just watch that and you can get the answer to this. What I'm going to do is do number 6, which is not on the instruction video, and then I'm going to leave number 7 for you to do. So you're going to do 5 with the help of the instruction video and 7 entirely by yourself. Okay, so here we are, we're in number 6. And again, all of these problems are essentially the same, except I've just given you different numbers of grams of CO2 and H2O. So it's just about doing repetition and getting kind of a sense of each of these steps by doing them over and over again. All right, so let's go ahead and do this one, and then I'll wrap this video and you do number 7 on your own. Okay, so you have 11 grams of CO2 and 5.64 grams of water that come from this reaction. So we're going to go ahead. It says write the number of grams of CO2 and H2O in the appropriate boxes. So this one's going to be 11.0 grams. It's in the CO2 column there. And 5.64 grams of water. All right, so there we go. So what we need to do is just the strategy again is to go from grams of each of these to moles of each of these substances. And then from that you figure out specifically the moles just of carbon and just of hydrogen, because that's really what we're interested in. And then we recognize that all of the carbon that's on this side, all the carbon that's on this side is here in the CO2. And the only place that carbon could have come from is here. So if we can figure out how many moles of carbon we have here in this box, that's going to be the same number that's in this box, and that's the moles of carbon there. And that'll be our subscript. Same with hydrogen. All the hydrogen that's on the right side of the equation here is here in the water. And the only place that hydrogen could have come from is also from the CH compound. So if we can figure out how many moles of hydrogen, which we're going to write there, that'll be how many moles of hydrogen we write there. This box actually belongs to the hydrogen over here, so I'll draw an arrow when I get there. Then we'll know how many moles of carbon, how many moles of hydrogen, and then we can go ahead and write our empirical formula. Okay, so let's go ahead and do that. There's the grams. Compute the molar masses of CO2. We've already done that, so let's just write the conversions. Okay, there's the molar conversions. So using the masses up here and these, let's go ahead and figure out how many moles of each substance we have. All right, so we'll start with carbon dioxide. Okay, grams of CO2 cancels with grams of CO2, and you have 11 times 1 divided by 44.01, and that gives us 0.2499, which we're going to call 0.25. Now for water, we do the same thing. Okay, we have 5.64 grams. Okay, so grams of H2O cancels with grams of H2O. So it's 5.64 times 1 divided by 18.02. And that's going to give us 0.3, call it 313 there. And again, this should be units of measure and substance, moles of CO2, and this is how many moles of H2O. Okay, so if we come back up here, where that would go is the This is 0.25 moles of CO2, and this is 313 moles of H2O. Okay, so we have moles of CO2, moles of H2O. But what we really want to get to is this up here, the moles of carbon and hydrogen. So there we are right there. So now we're going to go to the next page. And it says write two conversion equations to compute the number of moles of carbon from grams of CO2. So we started with this many grams of CO2. And let's see if we can write this without using the picture this time. So it's 11.0 grams of CO2. And it says it's two conversions. So the first one is going to be really the one we already did. We just did. We need to get to moles. So from grams to mole. Okay, and grams of CO2, grams of CO2. So that would give you, if you did that, that would give you this 0.25 moles. But now we want to go from moles of CO2 to moles of carbon. We want to know how many moles of carbon. So remember, the coefficient here that's not written normally is the 1 in front of CO2. And the coefficient on the C, or excuse me, the subscript on the C there is a 1, although you never write it. So you have 1 mole of carbon for every 1 mole of CO2 molecules. Okay, so let's go ahead and write that conversion. The moles of CO2 and moles of CO2 cancel, and the only thing we have left is what we really are interested in, is moles of carbon. So now we go ahead and do that calculation. So it's 11.0 times 1 times 1 divided by 44.01 divided by 1. And you can see if it's a 1-to-1 relationship, then the number of moles of carbon is going to be the same as the number of moles of CO2. So this is 0.25 moles of carbon. Moles of carbon. Okay, so all the carbon that's here could have only come from one place. There. Therefore, this number is going to get transferred over to here, and that's going to be 0.25 moles of carbon, which is going to be that subscript right there, that first question mark right there. That would be 0.25. At least that's our temporary subscript. Okay, now we do the same thing with water. So H2O. So we started with 5.64 grams of H2O right there. All right. And so now we need to convert that to moles. So we know our molar mass conversion. There we go. So we need grams to cancel out. So grams goes there and there. Okay. And what that will give us, if we compute that, that will give us this number that we already computed a little bit earlier. Okay. Now if we look up here, for every 1 mole of H2O, we have 2 moles of hydrogen. Okay, again, I use the bicycle wheels example. You need 2 bicycle wheels for every 1 bicycle you're going to make. If you want to make 200 bicycles, you need 100. Excuse me. If you want to make 100 bicycles, you need 200 bicycle wheels. If you want to make 1,000 bicycles, you need 2,000 bicycle wheels. You need twice as many of these as you have of these. So we need this. This is the number of moles of H2O. So if we want to know the moles of hydrogen, which is what this row is asking us for, it's going to be, I'll write it up here, it's going to be 2 times 0.313, that number right there. And that's going to give us 0.626 moles of hydrogen. Okay, this is moles of water. So write that here, H2O. And twice that number there is moles of H2. So this number of moles of hydrogen, it's all the hydrogen that's over here on the right side of the equation. It all had to come from one place, and that's right here. So that number, 0.626, goes here. Moles of hydrogen. And that is going to be that second question mark, that subscript right there. Okay, so we have 0.25 for carbon and 0.626 for hydrogen. Okay, so now what we are going to do is says make a ratio of the moles of carbon to moles of hydrogen with the smaller number on the bottom. Okay, so we're going to, for hydrogen, so the smaller number of these two is the 0.25. So we're going to put, for hydrogen, we're going to put 0.626 over 0.25. And let's come up with what that equals. That gives us 2.5. And for carbon, it's the smaller number over itself. So this number always, for the smaller one, always turns out to be 1. 0.25 over 0.25, and that equals 1. So you take both of them and you put them over the smaller one. So this one, they're different. You come up with that. This one, they're the same. So for this one with the smaller number of moles, it's always going to end up to be 1 there. Okay, so now we have a ratio of 2.5 hydrogen for every 1 carbon. So it says multiply top and bottom of the fraction. So we're going to write a fraction here. Hydrogen, carbon, 2.5 over 1. And we're going to multiply by whole numbers. We need to have these be whole numbers or integers. This one is, but this one isn't. So you multiply by 2 and then 3 and then 4 until you get both of these to be a whole number. So let's start with 2. 2.5 times 2 equals 5. Now you have to also multiply this one by 2 because you need to keep that relationship the same. So that's going to be 2. And so we did it. We now have a whole number and a whole number. So that means the molecular formula here, the empirical formula is going to be C2H5. There's 5 hydrogen and 2 carbon. So that's the empirical formula right there. That's the lowest ratio of carbons to hydrogen. You can't reduce that fraction anymore. Now that might also be the molecular formula. We don't know yet. So what we're going to do is go on and find out the molecular formula and see if that's actually it, or maybe it's something else. In order to do that, though, we need one more piece of information. So now we're going to move down here. We need to know the molar mass of the actual compound. Not this, but the actual compound's molar mass is 58.14 grams. So we're going to compute the molar mass of the empirical formula. We were given the molar mass of the actual molecular formula, that we don't know that formula yet, but of the actual compound. So what you do is you figure out the molar mass of this. So that's going to be C2H5. That's called the empirical molar mass. So carbon, you have 2 carbons times 12.01, which equals 24.02 grams of carbon. And then for hydrogen, you have 5 of those right there times 1.01, and that's 5.05. Now you add those two to get the empirical molar mass of that, and you get a 7 there, a 0 there, 9, and 2. So the empirical molar mass for this is 29.7. Alright, so now we're going to move on to the next page. Up here. And it says make a ratio of the molar mass of the molecule over the empirical molar mass, and that's called the factor. So the molar mass from the previous page, let's write what that formula is. N equals, that's the factor number, molar mass. A factor is just a number that you're going to multiply something by, over empirical molar mass. And so from the previous page, we were given the molar mass of the actual compound is 58.14 grams. And the empirical molar mass we just calculated was 29.07 grams. Grams cancels, so that means you have no units of measure, it's just a factor. So now we divide these two numbers and see what the factor is. And it's exactly 2. Exactly. So the factor N equals 2. So now what you do is you take the empirical formula C2H5 that we came up with previously, and you multiply each of these times 2. Multiply that times 2, multiply that times 2. And what you end up with is the molecular formula. This is your final answer. is 2 times 2 is 4, so it's C4, and 2 times 5 is 10, H10. And that is a molecule called butane, right there. Okay, so that is the end of the problem. Go ahead and do number 7 on your own. Number 5 you can do on your own with the help of the instructional video, because number 5 is done in the instructional video. Those are the same numbers used there. Okay, so that takes care of this lesson and this answers video. If you need any help, come to office hours and or to tutoring, and we will help you there. All right, we'll see you in class.